This is part 2 of section 8.2, and we're going to break down the big ideas. First of all, when we integrate the velocity function, we get position. So if I integrate v of t, we're going to get s of t. Since this is a definite integral going from a to b, we'd have s of b minus s of a. So this is telling us really the change in position from time a to time b, and we call that the displacement. That is our change in position. So big idea number 1. Big idea number 2. So when I know the displacement, I can figure out the change in position. So if I know the position of an object at time A plus the displacement, the change in position from time A to time B, I have my position plus the change in position. That will give us the position at t equals b. So this would be like a final position. This would be an initial position. And this is our change in position, or this is our displacement. So initial position plus change in position gives us a final position. Last big idea, if I want to know the total distance traveled, as opposed to just the change in position, I'm going to integrate v of t dt from a to b. But instead of just taking the velocity, if the velocity is negative, it's going to count it as a negative distance traveled, kind of. We can't have a negative distance traveled, so we're going to say take the absolute value of all that and what our distance traveled is equal to. All right, so for a few equations, v of t is equal to this equation. So I would make sure my calculator is in radian mode, go to y1 and enter this equation into your graphing calculator, because you're going to be using it for 4 different questions here. It's going to be easier if you just put it into y1 and then we can do all the calculations from there. And there is an initial position force, which will be pertinent to some of the problems. So when you're ready, you can put this into your calculator, see what you can do with those questions. When you're ready, go ahead and you can listen to the answers and look at the justifications. Part A says, is the particle slowing down or speeding up at t equals 4? So speeding up or slowing down, you need to calculate what is v of 4. Just plug it into the original equation. That comes out to about 2.979. And you want to compare that with the acceleration at 4. So find the derivative of this equation at t equals 4. Again, I'm going to use my calculator for that one. That comes out to negative 1.164. And I'm using my calculator rather than trying to take the derivative by hand, because this is a calculator active problem. What I notice is that the velocity and acceleration have opposite signs. So that means that this particle is slowing down because v of 4 and a of 4 have opposite signs. That's it. Question B, find all times in the interval where the particle changes direction, justify your answer. So for this one, I'm going to look on my graphing calculator from t equals 0 to t equals 3 and look at the velocity equation, look at the y equals. And what we'll notice is that there is one point where the velocity is equal to 0, and that is at t equals 2.707. And at that point, the velocity is changing signs from a positive and negative. So when does the particle change directions? At t equals 2.707, because v of t changes signs. There was a positive velocity, negative velocity. That is how I know it's changing directions. Question C, find the position of the particle at time t equals 0. I know the position at t equals 4. So the position at 0 is going to be the position at 4 plus the displacement from 4 to 0. So here's what I'm looking at. The position at 4, which is equal to 2, plus, and again, it's a calculator active problem, so use your integral function on the calculator to integrate that. Don't try to do this integral by hand. 2 plus that change in position is going to give us negative 3.815 for our position at t equals 0. Question D, find the total distance traveled from t equals 0 to t equals 3. Now, the most direct way to do this one is to evaluate not just the velocity, but the absolute value of the velocity from 0 to 3. And that's going to give us 5.301. The other way you can do that, which is going to be more difficult, is you could take just the integral of v of t dt from 0 to 2.707, and then minus the integral from 2.707 to 3, and we could figure it out that way as well, but it's much simpler to do it just as one big absolute value step. Question 2. So for this one, we're looking for a distance traveled, and what we know is that a of t is equal to 4. We're also told at time t equals 3, the velocity is equal to 16. So what we're going to do is figure out what is the velocity equation. If I integrate a of t with respect to time, I'd have 4t plus c. That's just taking the integral of acceleration. And since v of 3 is equal to 16, I'm going to plug 3 in for t, plug 16 in for v of t. So 16 equals 4 times 3 plus c. Subtract 12 from both sides and we get 4. So that means that my velocity equation isn't just 4t plus c, it's 4t plus 4. Next up, distance traveled. So I'm not looking for position, I'm just looking for the distance traveled. I'm going to integrate 4t plus 4 from, far does the particle travel when the velocity increases from 4 meters per second to 24 meters per second? So I need to figure out when that's going to happen. When does this velocity equal 0? So set 4t plus 4 equal to 0. And if I solve that equation, actually from 4, make this equal to 4 here. Solve this equation for t, we get t equals 0. So at t equals 0, we're at 4 meters per second. And then when does this velocity, this 4t plus 4, equal 24 meters per second? So set the velocity equation equal to 24. Solve for t equals 5. So from t equals 0 to t equals 5, the velocity is changing from 4 meters per second to 24 meters per second. This is my integral. If I take the value of this, or actually do the anti-differentiation, it's 2t squared plus 4t. I don't need a plus c because it is a definite integral. So here's the integral that we're evaluating. And then plug 5 in for my t values. 2 times 5 squared plus 4 times 5 minus, when I plug 0 in for those, it's 0. So this is going to come out to 70. And label is going to be meters. So answer D. Now, I wasn't worried about doing the absolute value of the velocity for my distance traveled because the velocity is always positive. Acceleration was positive. The acceleration starts at 4, goes to 24. The velocity must be positive for all those. So I don't have to worry about taking an absolute value sign or looking to see when the velocity goes negative. So for this one, I'm not worried about that.